Hello, I'm Single-Minded Ryan. In this video, I'm going to show you 3 essential effects for 2D Godot games. The first one is the sprite trail effect. The second one is the damage number effect. And the last one is how to create the 2D light and shadow. Alright, let's get started with the sprite trail effect. I feel like this is an essential effect if you are making a 2D game. By the way, the game you're looking at is from my Udemy Godot 2D course. If you're interested in my 2D course on Udemy, please check out the link in the description below. Alright, let's get started. First, I'll get into my player scene and talk about the general idea. In my player scene, there is an animated sprite 2D node that controls the animation of the player. Basically, it contains different animations for different states. And then I control the animation through the script. So to create the sprite trail effect, I am going to duplicate this animation sprite 2D a couple times. And I am going to stop the animation in the duplicated ones. So it's going to freeze at the time that it's duplicated. This way, we are going to have a sequence of sprites that follows the player. And the sprites are going to match the player's previous actions, and this is very important. I'm going to add a new node to manage the sprite trail effect. Right-click on the root and add a new child. I'm just going to use the basic node, because its only job is to hold a script. Rename the new node to sprite trail. Now we can add a script to it. I'm not going to change anything here, just hit create. In the script, we need a reference to the animated sprite 2D of the player. Let's hold the Control key and drag the animated sprite 2D into the script. Next, we are going to write the code in the process function. The process function is a Godot built-in function. Basically, it runs every frame after the physics is processed. First, we need to think about the interval of the sprites. I think I want to have a new sprite every 6 frames. My game runs at 60 frames per second, which means we are going to have 10 sprites per second for the sprite trail. To make this happen, I am going to use an if statement. I use the getFrame function to get the current frame number of the game. Then I'm going to use the modulus operator to find the remainder of a division. So basically, we are going to divide the current frame number by 6. Then we get the remainder. And the remainder is only going to be 0 every 6 frame. Then we know this is the frame to create a new sprite. Alright, let's duplicate the animated sprite 2D node of the player and store it in a new variable called newSprite. We can call the duplicate function on the sprite 2D node to make a copy of it. We also want to specify the type of the new sprite. This way, we can call the class functions on it. We also will have access to its class properties. Now let's call the stop function on new sprite to freeze it. By the way, I'm sorry for the confusing name, even though this variable is called newSprite, but it's actually an animated sprite 2D. And by calling the stop function on it, at the time we duplicate it from the animation sprite 2D of the player, it should be play the same animation as the player at the same frame. So this is going to freeze it at that frame. Next, this new one is not in the game scene yet, so we need to add it to our game scene. I use the getTree function to get the game scene, and then we call the addChild function on the root property of it. This is going to add our new sprite to the game scene. Next, we want to set the global position of the new sprite to the player's global position. So we need a reference to the player. Let's drag the player to the script while holding the Control key. And then we set it to the player's global position. But in my case here, I still need to add an offset to the position. Let me show you why. My animated sprite 2D node actually has an offset from the central point of the player. This is because I want the pivot point of the player in my game to be at its feet. So I offset my animated sprite 2D node, and I need to add this offset in the script to make the new sprite match the same position. But again, this is just for my specific setup. You might not need to do this. All right, let's add the offset to our new sprite. Then I think this is a good point for us to run the game to test. I'll activate my game level scene and press the F6 key to run the game. Okay, it seems a little bit messy, but at least we know the code is working. For now, the new sprites are in front of the player. We want to put them behind the player. We can do it by changing the z-index of the new sprite. In my case, the z-index of the animated sprite 2D node of the player is 100. So let's decrease the z-index of the new sprite to 0, and this is going to put it behind the player. All right, it looks better. Now the sprite tail is behind the player. Let's go back to the player scene. Now the sprite tail is too solid, so we want to make it transparent, and we want it to fade out after a while. To do this, I want to add a new script to the animated sprite 2D node under the player. We don't need this script for the actual animated sprite 2D node of the player. But since we are duplicating new sprites from this animated sprite 2D node, the new copies are going to have this script on them automatically. And then we can make the new sprites fade out by calling a function we are going to write in this script. By the way, I call the script sprite fade. Then I am going to make a new function called update alpha with a float parameter called new value. We want to update the alpha, so let's go back to the 2D view to check out what property should we modify. We can see there is a modulate property in the animated sprite 2D node. And in it, we can change the alpha value of the sprite. We can hover the cursor over modulate to see the property name in the script. All right, let's go back to the script. Let's just set the a value of modulate to our new value. This is going to update the alpha of the sprite with the parameter of this function. Next, let's create a new function called start fading. This is going to be the function that we call to tell the sprite to start fading. To make the fading animation, let's create a new tween. To simply put, tween is a way that we use in Godot when we want to create an animation for a property in the script. This line is going to create a new tween and store it in the variable called new tween. Then we can set up the tween by calling the tween method function on it. Let's pass in the name of the update alpha function as the first parameter. So the tween is going to call this function every frame. The next parameter is the starting value for the parameter of the update alpha function. Let's set it to 0.8. So the alpha of the sprite starts at 80%. The next one is the end value. Let's put 0.0. So the alpha is going to become 0 at the end of the animation. And the last parameter is the duration of the animation. Let's set it to 1 second. All right, let's go back to the sprite fade script to call this function on the new sprite. For now, Godot cannot help us find the function name since we haven't defined a class. So let's go back to the script and copy the name. Now the sprites in the trail should fade out in 1 second. Let's run the game to test. All right, it looks pretty good to me. At this time, you might think we have finished the job, but actually we have a huge performance problem if we just leave it here. You can see on the left side in the scene window, we have countless new objects. These are the animated sprite 2D nodes we just duplicated from the player. And the list is growing longer as we speak, since we are duplicating new nodes every 6 frames. This is going to lead to performance problem, and it's probably going to crash your game eventually. The solution is going to recycle the sprites. So whenever a sprite is completely fade out, we reuse it as a new one. So basically, this is a very common technique in game development called the object pool. We often want to recycle and reuse the objects that are not in the game scene rather than generating the new ones. And you'll find this solution very useful in many different cases. Of course, there are many different ways to implement this idea. To keep this video short and easy to understand, I'll just use an array. So at the top, I declare a new array called sprite array. And the type of the array members is animated sprite 2D. Then let's create a function to set up the array. I'm going to call it setup sprite array. Then let's use a for loop to create 10 sprite members for the array. I'm going to copy some script from the process function to the for loop. These lines are going to duplicate a new sprite from the animated sprite 2D of the player, and then set up the new sprite. Let's also comment out the remaining 2 lines in the process function and add a pass keyword to make this function do nothing. Let's also change the alpha of the new sprite to 0 right after it's duplicated. Then the most important thing to do here is to add this new sprite to our array. So by the time that this for loop is finished, the array should have like 10 members. All right, to actually set up the array, we need to call this function in the ready function. The ready function is going to run at the beginning of the game. But when the game starts, we immediately get many error messages. It seems like the problem is related to the line where we add the new sprite to the game scene. Basically, the message says we are doing this at the runtime while the parent node is busy doing its own stuff. So let's update this line with the call deferred function. The call defer function is going to do the same thing, but it's going to do it in the next frame. All right, let's run the game again. Now the error messages disappear. And we can see we have exactly 10 animated sprite 2D nodes in the game. So we know the code is working, and we just need to cycle through these nodes for the sprite trail effect. So let's do it in the process function. Remove the pass keyword. And the first thing is to check if the array is not empty, because we don't want to do anything when there is no sprites in the array. Let's call the isEmpty function on the array. And we only want to do something when the return value is false. The first thing to do is to get a sprite from the array. Call the pop friend function on the array. This function is going to remove a member from an array and return it to us. And we are going to cast the return value to animated sprite 2D and store it in a variable called sprite. We also specify the type of this variable as animated sprite 2D. So we have access to the properties of the animated sprite 2D. One thing to notice is that previously we only needed to stop the animation on the new Sprite 2D, since the animation was in sync with the animated Sprite 2D node of the player, because the new one was duplicated from the animated Sprite 2D node of the player. But this time we are getting a new sprite from the array, and this one is definitely not going to be in sync with the animated Sprite 2D node of the player. So first, we need to set the animation of this sprite to the same animation that is playing on the animated Sprite 2D node of the player. And we also want to sync the frame of the animation. All right, then we can uncomment these two lines and replace the variable name. So these lines are going to set the global position of the sprite and start the fading effect. Now the sprite trail looks good. But we don't get any more. That's because we are not recycling the sprites. Let's go back to the script. And at the bottom of the if block, let's tell the engine to wait for 1 second. We use the await keyword. Then we create a timer. Set the timer to 1 second, which is the duration of the fading animation. And after 1 second, this sprite should disappear on the screen, so we can recycle it by adding it back to the array. We can call the append function on the array to add the sprite back to it. All right, let's run the game to test. Great, the final result looks pretty good to me. For now, the sprite trail effect is enabled all the time. You can use it in many different cases. In my demo here, there is a small problem. The trail is always on when the player is not moving. I think it's a good idea to disable the trail when the player is not moving. So let's go back at the top of the process function. We want to check the horizontal velocity of the player. We already have the reference to the player, so we just check its velocity.x. And when this value equals 0, that means the player is not moving. In this case, I'll just put the keyword return here. So the rest of the code is not going to be executed. All right, I think this looks perfect. I hope you got the general idea of how to create this effect. First, I'm going to add a label node to my enemy scene file. Rename the label node to damage label. Let's just put a placeholder number in the text field. Set horizontal alignment to center and vertical alignment to center too. Then go to transform under layout. I'm going to set the size of the label to 50 by 30. And we want the pivot point to be sitting at the center of the label. We can do that by setting the pivot offset to half of the size. Then let's make the size of the text smaller by decreasing the scale to 0.4. Notice that I do not decrease the font size of the text, because that is going to make the text blurry. Next, we want the label to be on top of everything else. So let's set the z-index to 100. Then I'm going to add a new script to the label. This script is going to animate the label, so it looks like the damage number floats upward. But before we start writing the code, let's convert this damage label node into a scene file. Just drag the node into somewhere in the project folder. And we actually don't need it in the enemy scene, since we are going to instantiate the damage number every time the enemy gets hit. But before we delete the damage label, we need to find out the right position where we want to instantiate it. So let me just move the label to somewhere above the enemy. I think this place is great. And we can go to transform to check the position. The position is -25 and -70. This is the relative position to the center point of the enemy scene. And we need to take note of this position, since we need it in the code. Alright, now we can remove the damage label node. And let's switch to the new script we just created. Before we continue, I want to briefly mention that the project that I am using here is from a new Godot course on Udemy. The course is going to help you understand how to make a 2D top-down game with Godot from scratch. I'll link a discount coupon in the description below. Please consider to give it a try if you're interested. Alright, go back to the video. First, we want to animate the label, and we can do it in the built-in _ready function. In the function, let me create a tween for the animations. First, I want to make the damage number bigger. Then I want it to move upward. Then I want it to become smaller until the size becomes 0. I'm going to divide all of these into 3 animations. Let's set the tween to parallel, so all of the animations start at the same time. This is going to help us manage the timing of the animations easier. For the first animation, let's call the tween property function on the tween. And we want to change the scale property. The target value is 0.7 and 0.7, and the duration is 0.2 seconds. So this animation happens really fast. For the next animation, we also want to animate the scale property. This time, the target value is vector2.0, and the duration is 0.5 seconds. But we want this to happen after the first animation. So let's set the delay to 0.4 seconds. For the last animation, we want to change the Y value of the position, and we want the damage number to move upward by 80 pixels. And the duration of the animation is 2 seconds. Let's also set the delay to 0.4 seconds, so this animation starts at the same time with the second one. The last thing is to remove the damage number from the scene after all the animations are finished. And that's it for this script. Next, we need to instantiate the damage number whenever the enemy is attacked. The code that damages the enemy is in my base character script, so let's go to this script. You can ignore all of the code in this script since it has nothing to do with this video. Just focus on the code I'm about to write. First, we want the damage label scene file. Let's hold the control key and drag it into the script. Then let's go to the getHit function. And let's add some code under the line that damages the enemy. In fact, this script is also used by my player, so we'll also see the damage number on the player when the player is attacked by the enemy. Go back to the script. Let's first initiate a new damage number using the scene file. I'm going to store the result in a variable called newDamageLabel. Notice that I cast the newDamageLabel into a label node. This way we can update its text property. So let me just set the text property to the damage that the enemy just received. Next, we need to update the position of the newDamageLabel to the position of the enemy. And we also don't want to miss the offset value. This way, the number is going to appear on top of the enemy. Then we need to add the newDamageLabel into the current game scene. Notice that I don't want the number to move with the enemy, so I just add the newDamageLabel to the rule node of the scene. Alright, we have finished, and this is the final result. I hope you've learned something new, and please check out my new Godot course on Udemy. First, let's add a point light 2D node to the player node. Then let's create a gradient texture 2D. Set the fill property to radial. Now we can tweak the black and white colors to create a mask for the light. Let's increase the size to 512 by 512. Increase the energy to 6. Let's tweak the colors a little bit more to make the mask as soft as possible. Now we can enable shadow. Next, I'll select the tile map layer node of the wall and add a new occlusion layer. Go to the tile set panel, select paint, and select the new occlusion layer we just added. Now I'll just paint all of the tiles so they can block the light and cast the shadow. Alright, now we can see the shadow. But we have a problem here. The light also brightens everything in the game. And the player can get into the shadow when it's close to the wall. This is not what I want. Before we continue, I want to briefly mention that the project I'm using here is from my latest Godot course. I just released it on Udemy. The course is going to help you understand how to make a 2D top-down game with Godot from scratch. I'll link a discount coupon in the description below. Please consider to give it a try if you are interested. Alright, go back to the video. Let's go to the player scene and select the animated sprite 2D node. We can exclude this node from the light. Also, I want to exclude the shadow sprite from the light. Next, let's go back to the main scene and add a world environment node. Create a new environment. Set mode under background to canvas. Then let's set the tone map to ACES. Let's also darken the background and the wall. One last thing, if you want the shadow to look soft, you can change the filter of the shadow to PCF13. That's it for this video. I hope you've learned something new. And please check out my new Godot course on Udemy. Thanks and see you next time.